Hello everyone, I am your friend Shadab Imam and we are currently dealing with the topic of CPM and PERT. In order to solve the problem of CPM and PERT, we must understand how to construct a network diagram. So in this lecture, we are going to see how to construct a network diagram, rules for network construction and how numbering of events takes place. So please watch this video till the end, and if you are new to the channel, please subscribe the channel and don't forget to hit the bell icon. So let's move on to the problem here. Here we have one problem where we need to construct a network diagram from the below table, and as we see in this table there are activities given and the activities are presided by certain activities. So before moving on to construction of network diagram, let us understand what are the rules for network construction. So the first is no two activities should have the same starting and ending event. So this says that no two events, suppose this is starting event and this is finishing event, no two events can have the same starting and ending events. Let us suppose this is activity A and this is activity B. So these two events cannot have same starting and end event. Now in order to remove this type of situation, we will use a dummy activity, and later on we will see how we can use the dummy activity here. As of now, it is understandable that two activities cannot have same starting and ending event. Now second says that the activities are put in a logical sequence based on the precedence relationship. Now it says that activities are based on some precedence. That means if an activity A and activity B needs to be carried out, and we know that activity B can only start when activity A is completed. So we can say that activity B is presided by activity A. Okay, so this is called precedence, and we need to take care of this precedence while drawing the network diagram. Now let us move on to the third point. It says that if needed, use dummy activities to show the logical relationship. So here in certain network diagrams we need to use the dummy activity, and the dummy activity is the activity which does not consume any time and resource, and the reason dummy activity is used is just to follow the precedence, and it does not carry any resources. So let us assume this situation again. If there are two activities are falling where both are coming as same starting and ending point, then to avoid certain situation we can use a dummy activity in this form: activity A or activity B, any one of the activity and this is your dummy activity. Dummy activity is generally showed by a dashed line, and this dummy activity can be placed anywhere. So this is a proper network notation, and similarly we also can done this. This is dummy activity, this is activity A, and this is activity B. So this can be also written in this form, and similarly dummy activity can also be added with activity B on either sides, just as in case of activity A. So dummy activity is just showing the precedence. That means at this point of at this event or node, the activity A is completed as well as activity B is completed. Similar is the case here. So we are following precedence without having two activities getting same starting and ending point. So first is the dummy activity can be used in this manner, or there are situations where, let us assume a situation, if there are four activities A, B, C and D. Activity A and B does not have any precedence, that means they are not preceded by any activity, and activity C is preceded by activity A, and activity D is preceded by A and B both. Now in this case what happened is, we can start the unpreceded activity from the starting node, that is activity A and activity B. Now from here we can see that C is preceded by A only and D is preceded by A and B both. So if I need to draw here activity C, this is correct because activity C is starting where activity A only is completed. Okay, now if I need to draw activity D, then I had to use a dummy, activity which is showing the precedence of A and B both at this event or this node. So this node is showing that at this particular point activity A is completed as well as activity B is completed. So we can start after this activity D, which is AB. Okay, so this is the use of dummy activity, and in the network construction we will see how we can use the dummy activity judiciously. So let us move on to the next point. Each activity is represented once and only once in the network diagram. That means every activity that has been mentioned can only be drawn once in a network diagram, and then there is only one starting and ending event in the network diagram. So this is very important because we could not have multiple starting or ending diagram of a network. As in this case we can see that activity A is not preceded by any activity, activity B also is not preceded by any activity, but we need to understand that both the unpreceded activities are starting from the same node, and we cannot individually start activity A from other node and activity B from other node. That will be wrong. So we need to understand that no matter how many unpreceded activities are there, all the unpreceded activity must be started by a single node, and at the end when all the remaining activities are open, we need to converge these remaining open activities to a single node or event, and this will be the finishing event or finishing node in a network. So as per this four activities, this is our starting node where unpreceded activities A and B are starting, and this is our ending node or finishing node where all the remaining open activities are ended here. So this is the network diagram as per this simple activities. Now let us move on to the problem we have taken. And we also need to see how how the numbering of events take place, and we will do it after we will construct a network. So in this particular network we can see that activity A, B, C and D, all the 4 activities are not preceded by any of the activities. That means they are independent and they can be started simultaneously. So as of this, we can start these activities as activity A. This is activity A, then activity B, then activity C, then activity D. Now we will not make a finishing event for any activity until it is required. So all the activities right now are open activities, and as we move further we can see that activity E depends on A and B both. So activity E here is preceded by activity A and B, and there is no other activities which is preceded by A only or B only. So as we can see that if we will draw an event here and join activity B also here, it will violate the first condition where it says that no 2 activities should have the same starting and ending event. So again we need to do what we need to do is we need to have a dummy activity here which will show the dependency. So this is a dummy activity, this is first dummy activity, and at this point it is showing that dependency of B as well as dependency of A. So we can see activity E can be started from this node, and activity cannot be started from this node because it has at this node only activity B is completed and dummy activity is started from this point. Because arrow is showing upward, that means this is showing the dependency of only activity B, and this node is showing dependency of activity A as well as activity B. Now moving on to activity F. F is preceded by E. So here after E is ended, activity F has been done, and then activity G is preceded by activity F. Activity G is preceded by activity F. Then activity H is preceded by activity D. Activity H is preceded by activity D. So here activity D ends and H is preceded by activity D. Now activity I is preceded by activity G and H both. So we can see that here is activity G and this is activity H. So activity I is preceded by both these activities. So we need to converge these 2 activities to one single node, and this node shows that activity G and activity H are completed here, and I activity can be started from this particular node. Now activity J is preceded by C and I. So we can see that activity C is here. So again we need to make C here. So this is activity C and activity I, and from this event activity J has been started. Now once this has been finished, we will see how many open activities are there. So we can see that only J is open here right now. So we will terminate this at this particular event. So now our network construction has been done. and now we need to number the events here, and the numbering of events is done by Fulkerson rule. Fulkerson has given a rule for the numbering of events. So let us see how we can number the event in a network. First is the initial event which has all outgoing arrows with no incoming arrows is numbered 1. So we can see here that the initial event, this is the first initial event where all the arrows are outgoing arrows and there are no incoming arrows. So we can name this number 1, event number 1. Now delete all the arrows coming out from node 1, that means this event 1, and this will convert some more nodes into initial nodes and number these 2, 3 and etc. So what we will assume is that all the outgoing arrows from this particular node are erased. So let us assume these are erased. So after watching this, we can see that we will have new initial events which are having outgoing arrows and no incoming arrows. So we can see that if activity D has been erased, this will have only one outgoing arrow, so this can be termed as 2. Similarly, if this activity B has been erased, then it can be assumed as initial event because it has only one outgoing arrow, so this can be termed as 3. Next, if this, we will consider this, and because there is one dummy arrow coming at this point, we will label it afterwards. So let us see what it has been given. Delete all the arrows going out from the numbered events to create more initial events. Assign the next numbers to these events. So we will continuously doing this, that after 3 we will delete the outgoing arrow, that means we will delete the dummy arrow, and activity A has already been assumed as deleted, that means this can be the initial event, or we can say that from this event only outgoing arrows can be seen, so this can be termed as number 4. Similarly, if we delete activity E, then this will become initial event, so this will be 5. Similarly, this will be 6 and this will be 7, because activity H is deleted and activity G is deleted, then this will become initial event. Similarly, this will be 8 and this will be 9. So this is how the numbering of events can be done, and the final point here says that continue until the final or terminal node which has all arrows coming in with no arrows going out is numbered. So the last arrow, we can see that all the arrows are coming in and there is no outgoing arrow, so this is the terminating node or final node here. So we have seen here how to construct a network with an example, and we will do such more examples to see how to construct a network diagram with different problems. If you like the lecture, please share the lecture. Have a nice day. Thank you.